Hey guys, today we will discuss the low level design of a snake game. Before we start with the design, I would like to add that my focus here would be to design considering an entry level position, for example SDE1. So I would be more focused on breaking down the problem, collecting the basic requirements and identifying the different objects. So before we work on the design, we need to understand what is the expectation in an interview. The interviewer for an SDE1 position would expect an interviewee to understand the problem and collect the necessary requirements. Now, collecting the right requirements is the key for successfully completing the interview and coming up with a good design. So, let's start with the snake design problem. In an interview, the interviewer would try to be very abstract while giving up the problem, and they would expect the candidate to ask questions to understand the problem statement. So, in a low level design interview, the first step is to understand the problem. In this case, when the interviewer asks to design the snake game, you may directly jump to the requirements phase. But what if the question is very vague? Let's say the interviewer asks you to design a Mars rover. In such kind of a problem, before jumping to the requirements phase, we should narrow down the problem. For example, the Mars rover could do several things, but the core part of the Mars rover is to move on the Mars. So our problem now is to design a solution that could be used for a robot to move. Once we narrow down the problem, we can work with the requirements, identifying objects, and come up with a simple solution. For an SD1 interview, this would be fine and would be what the interviewer would be expecting. Now let's jump back to the snake design problem. For the requirement phase, we can start by proposing a possible design. For example, we can consider that in a snake game, there would be a n cross n board containing a total of n squared cells. The board would have a snake that would grow as the snake eats fruits. So this is basically what we if you have played a snake game on a mobile phone. So let's imagine something like we have been given a board of n cross n. So here we are taking n as, let's say, 5. So there would be n squared cells in this board, and so each of this is nothing but a cell. So you have been given a board, and board consists of cells, and we have a snake. Let's say initially one of these cells would be marked as a snake, and the snake would grow as it eats fruits. So on the board, the same cell could be also represented as a fruit, and that's what a very simple design would look like. So in the game, the user would move the snake to eat the fruits available on the board without touching the head of the snake to its own body. If the snake touches its own body, then the game is over. Normally, if you see in a mobile phone, the snake would be in motion and the user would just control the directions. But for simplicity, we would say that the snake is at still and the user would control its direction, whether to go up one step, down one step, or go back in one step. We can discuss these requirements and your ideas with the interviewer. The interviewer would either agree or request some changes, but overall, if you see, this could be our simple initial requirements to move forward with the design. Once we have identified the requirements, the next step is to identify the different objects. So if we see from our requirements, we can clearly say that, so let's say that for our objects, we can see that we would need a board object. So one of the object would be a board. The board would be made up of cells. So we would have an object of cell, the board and the cell, and then we need a snake. So the game would have a snake. The game would be played by a player. So there would be a player object. We can see that there would be fruit, so we can just say the fruit would be an object. And then we would also have a game object because the game would eventually have the player, the board, and the snake and the fruits. The board would then also have cells. So the main class would be the game, then we would have different object classes in that, and the board class would have a cell. Once we have this objects, the list of objects, the next step would be to design simple implementation of each. Like taking this object, we will design classes and come up with a very simple classes for each of the objects. So the first class could be a very simple one. So let's start with the board class. So we could have something like a board, and the board would be made up of cells. So we would have a matrix of type cell. So that would be a 2D array basically. Let's say we just call it as a matrix, and matrix is made up of cells. So we will define this class cell separately, and we can just have designed like a simple maybe constructor over here, which could take the x and y this x and y is nothing but what are the sizes for the x and the y coordinates. So we can, in this constructor, we could just define the matrix. So the matrix would be equal to new cell x comma y. So that's what the board class would look like. And so the next class would be a cell class, because the board is made up of cells. So let's discuss that. So when we talk about the board is made up of cells, and the cell, if we talk about it, could be just an empty cell on the board, or it could be a cell which is representing the snake. So initially, a snake is of just one cell, but eventually it will grow, and it could be, let's say, all these cells are the represents the snake, and that could be a cell which could represent a fruit. So the snake would have a head and would have a tail, and the user would move the head of the snake to reach to the fruit. So if we talk about the cell, can be of different types. It could be either a snake, or it could be either a fruit, or it could be just a normal empty cell. So let's just start with the main class. So let's say we have a class called as a cell, and the cell basically would have an x and y coordinate. So it would have an x and a y coordinate, and it would for now we can just define like it has some value, and we could just have a simple constructor for this one, which initially would determine the coordinates, and we can just define this dot x is equal to x, and this dot y is equal to y, and we can have this dot value is equal to 0, and this would be our basic cell. And then we can have a snake cell. So the snake cell would look like the class snake cell, and it would extend the cell. Now here you have to understand whether you want to create the cell as an interface, or as an abstract class, or just a normal class. Now since we know that that would be an empty cell, so for that purpose I would actually have a cell as a class. We can also define an interface and then create a normal cell out of it, and then create the extend the cell class to have a snake cell, and then maybe have another class called as a fruit cell, which again extends the cell class. So this could be our basically simple design. Let me know what you think, whether it should have an interface or just having a class sounds good. So in talking about a snake cell, the snake cell would be very much similar. We can just have a constructor, because the snake cell would, since it is extending, it would all have the property of the integers, I mean the coordinates and the value. So it would be like a snake cell constructor would just take in the x and y value, and just call the super, like the constructor of the parent class, and the value could be, we can have a different value for each kind of a cell. So for example, here we have set the value as 0. Let's say that for the snake cell we just set the value as 2. This is just to like represent, maybe when we have an actual implementation, we can maybe make use of this value. And for the fruit cell, again we will have the similar kind of a constructor. So it would again take x and y, and just call the super, that is the parent constructor, and then set this dot value as equal to 1. Another thing what we need to understand is, when we are moving the, so basically let's say if we have this is our snake, so the user would move the head of the snake in different directions to reach to the fruit. Let's say if the snake, so basically the game method would have we will talk about it later, but for now just understand that the move method would take the destination cell coordinates, so where you want the head of the snake to move to. And if the destination cell is a normal cell, or maybe we can say an empty cell, then we would do some operation. And if there is suppose it was of the cell which the snake head is moving to is basically, let's say this was a fruit cell, then we would increase the size of the snake. So we need some method in our cell implementation which could behave differently based on what is the destination cell. So if, let's say, the cell was just a normal cell, like an empty cell, then what we really do, for example, if we have this board and we have a snake of size, let's say 2, and this is our head and this is our tail. So if you're moving the head, let's say down at this cell, the cell is just an empty cell. So what we do is we just move the head. We move the head one uh, head down, and we move the tail. So basically, we just move the snake one position. So we can have a method. Let's say for now, I can just name the method as execute. So this execute method would just take the snake as an input, and it could just move that basically snake. So we could have some implementation over here. We shouldn't be discussing the implementation a lot over here, because we are more focused on the designing. If we have time, we can discuss further in that interview, but otherwise we can just say that this execute method's job would be to take the head of the snake, basically go through all the cells of the snake and just move them one position. For the snake cell, the similar method would be there, but in the snake cell what we need to do is, let's say, so what does that really mean is, for let's say that if we try to override the method execute over here and we pass the snake, what that really means is that we are in the snake cell, and if you're calling the execute method, that means our destination cell basically is nothing but a snake cell. So in that case we need to terminate. So here we would have the logic to basically terminate the game, because the destination cell is actually a snake. And similarly for the fruit cell, we would have similar kind of implementation. So we have an execute, we take a snake as an input, and in that what we know is basically we have been passing the destination. So we have the snake in our as the parameter in our execute method, and we are calling the fruit cell. So here it represents the destination is a fruit cell. So what we need to really do is nothing but just increase the the size of the snake. And that would basically mean that if we have a board and we have a snake, let's say of size 2, and this is the next fruit cell, then we just make this cell as a snake basically, and the new head is this one, and the tail is the same. So yeah, just we just make the new cell as a head. And yeah, so let's start with the snake class. So the snake class, if you think about, so when we have a board, the board is made up of cells, and the cells represent the snake. So let's say if this is a snake, then we need a reference to the head and the tail. So the snake would have a snake cell, let's say the head, and the snake cell which represents the tail of the snake, and it would also have something to represent whether whether the snake cell, I mean the snake itself, is dead or not. So that would be when, when the, so let's say if the snake grows too big, so this is our snake, let's say, and this is our, let's say, the head, this is the tail, and if the next jump is to this particular cell, then the snake, uh that the destination cell is nothing but the snake, so we terminate the game. So in that case we would have whether the snake is dead or not, so we can just have a boolean flag to identify that. So initially we can say that the dead, but it's not dead, and we could have an integer variable for storing the snake size. So that would be the parameters in the snake, and we can define a snake constructor which would basically take some parameter, and the job here is basically to take the board and randomly select. Initially, let's say if we will, in our requirement we have, we will create a board and we will randomly select one of the cell as a snake. So here we would have to pass the board to the snake class so that it randomly selects one of the cells as the snake and updates the head and the tail and also the snake size. So that's what the snake class would look like. And we can actually add one more method over here. We have the parameters is private, so we can just have a getters or setters, or maybe we can just define whether a method called, so yeah, we can just have a setters and getters, and we can have a method, let's say, called as set dead. So, or maybe, terminate the game, or maybe I would say the terminate the game class would, the game class actually should have the method terminate the game. For the snake class, its responsibility is just whether to identify the snake is alive or not. So when we say that set dead, we would just take a boolean over here whether to set it or not, and we can just say that this dot dead would be equal to the dead. Or in turn, actually, when we are saying set dead, it um, really means that, we are trying to identify that the snake has deaded. So we can actually not even pass something over here, and we can just say that it is set to true. But that's a design choice. For now, anything could work. So let's jump to the next class, which is the game class. The game class would be very simple. It would basically have the game class is the main class, and it contains the board. So let's say the board would be represented by board. There would be a player. So we haven't defined the player class, but a player class would be very simple. It would just represent the player information. So I won't go into the definition of a player class. And we have a snake, and there would be an integer to maybe just count the number of fruits which are consumed by the snake. Now, we haven't really defined like what is the real aim of this game. So if you have been given a board, it randomly generates the fruit on the board, and the user's task is to eat all the fruits. But eventually the snake would grow, and the snake size would be maybe equal to the board. So in that case, I think the game we can just define the game as finished, or maybe the game is successfully uh, finished, and we can just return how many number of fruits that were consumed. And the more number of fruits you consumed is basically would give you more points to the player. So that would our the snake game would be. And we can define a simple constructor over here. So the constructor would just take the x and y. The x and y nothing but the size of the board. And in the constructor we would first define the board. So we will call the constructor of the board class and pass the x and the y. The next we can define is a player. So we haven't defined, but let's say we have a player class, and we just create a object of the player class. And the snake, so here we can actually pass some parameters of the player, like the name or some information, but for now we will just keep it blank. We can define the snake object, and when we define the snake object, as we have already discussed, the snake object would take the board. So we will just pass the board because it randomly then has to select one of the cell. Initially it has to select one of the cell as the snake. So that's what this would do. And the next job would be to create a fruit on the board. So we can actually have a method called as create fruit, and this would basically so in this case also the create fruit method, we can just define it in this game class itself. So actually, we didn't really discussed about how the fruit class would be defined, but actually the fruits, on the game, the fruit could be either an apple, or it could be a pineapple. It could be anything. So actually, we will have a fruit class, and the fruit class could have a different type of fruits, but we won't go into that much detail for now. So let's say when we call the create fruit method, now we will define the create fruit in the game class itself, but actually we can have a proper fruit class, and the create fruit can be defined over there. So we won't define the construction over here, but the create fruit just takes the board, and it randomly selects from the available. So from the available cells, it select one as the new fruit cell. So the main method here would be to have a move method. So let's say that we define a move method, and I don't know what should be the return type. So let's for now just define the method without the return type, and maybe we can either return a boolean just to say that the move was made successfully, or maybe we can just uh, return void, not to represent anything. And the move basically would take a destination cell. So ideally the user could just provide the x and the y coordinate, or I would say the user could just provide, maybe we can have a direction, and there could be different direction, either it could be -1, +1, 2, and a -2. So depending on our application, either if we are at this particular cell, then the -1 could be like going to the west and one direction to the east, or it going to the north and south. And for north and south we can just represent as +2 and -2. So that basically depend on your implementation, but for now let's say if we have this, then the user would actually just pass the integer direction. And since the game class has reference to the snake, so we know the snake head. So move basically function is being made in reference to the snake head. So we have a board, and we have a snake, and when we say that we want to move down like toward the south, we're basically taking the head of the snake, and we are moving it down one step. So since we already have the reference to the snake head, and we know that we want from the direction, we would know whether you want to go up or down, or left or right. So we can use the head and the direction which we want to move, and from there we can determine what is the destination cell which the user wants to move the snake to. And based on whether the destination cell is a fruit cell or just a normal empty cell or a snake cell, we would take the destination cell object and make a execute call. And since we have execute overridden in the fruit cell class, in the normal cell class, and the snake cell class, it would do different operation accordingly. And uh, yeah, so one thing we didn't add in our fruit cell class was to, in the execute method, we increase the size of the snake, and then maybe we want to create a random, maybe we would actually call a create fruit um, method. But since the create fruit method is inside the game class, so we cannot actually make the call from directly from the fruit cell. So one idea would be to actually have a different fruit class and have the method over there. Or since we have the create fruit in the game class, after making the execute call, let's say if the destination cell was a fruit cell, you make the call, it increases the size of the snake, and then in the snake, I mean in this move method, we can just check if the destination dot cell value, so we can just check if the value was equal to 1, then we know that it's a fruit cell. So we just call the create fruit method, and it will randomly create a new fruit. And similarly, if there was a snake, the destination cell is a snake cell, then what we need to do is we need to check. So we can again have if the destination, I mean we just have the destination and the dot value, if it is equal to 2, then we know that it's a snake cell. So we know that it would have terminated, so we can actually terminate the game over here. And we can do that. Or if we don't want to do this if part, then we can just check if the snake is dead or not. So if it is dead, then it would be dead only if the destination cell is a snake cell. So there are different ways to implement it, but ideally that's what the move method would be, to determine what is the destination cell, make execute call. If the Since we haven't defined the fruit class, we have to make a separate call to create the fruit, and we have to just determine if the snake is dead or not. And yeah, and one thing also in the move method we need to do is determine if the snake size is equal to the board's size. So since we have defined x into y, so we will have, let's say if x and y both are equal to, let's say, n, then we have n square cells. And if the snake size is equal to the number of cells in the board, then we know that we have reached the end of the game. So we can just determine that the end of the game, and yeah, just determine the results, the number of points which have been made, the number of I mean the fruits which were collected or consumed by the snake, and just end the game. Yeah, so that's basically what the basic snake game design would look like. And I believe this is not like a very advanced design, but for an SDE1, the basic step is to just collect the right requirements, identify different objects, and just come up with a very simple solution that could actually work. And I think, yeah, that's it for this video. See you next time. Thank you so much.